All right, so this unit is all about finding the area of a triangle. Now, in geometry, y'all found out how to find the area of the triangle. Area is 1/2 base times height, or base times height divided by 2, which is all well and good if you know if it's a right triangle or you know the height and the base of the triangle. But if it is not in one of those forms, then it can get a little tricky. So for example, let's say I had a triangle that's not right. It's a little wonky. And let's call this A, B, and C. And let's suppose that this side here is 80. Side C, the side baby C is going to be 20. And the angle is going to be, angle A is going to be 50 degrees. Right now, we had the base is 80. However, the height, we don't know the height here. Here's the height. Now, it's not to say that we couldn't find it, right? This is a right angle right here. We could use some sine action here, right? If I got 50, that's opposite and hypotenuse. So we could say that the sine of 50 is equal to h divided by 20. And solve for h, we'd multiply by 20 and get 20 is equal to the sine of 50, and that would be h, right? And we could figure out the approximate value. We're not going to do that right now. Instead, what we are going to say is that h, in this case, is actually, 20 is actually side baby C, right? So h is actually side C, and we're talking about the sine of angle A, the sine of angle A. So h is actually side C times the sine of angle A. Now, if we did do area is equal to 1/2 base times height, what we could say is that area equals 1/2 times the base. Now, in this case, what would be the base? Well, the base is 80, or in this case, side B. So side B times the height. And the height we just solved for is C times the sine of A. C times the sine of A. So the area of a triangle is 1/2 times side B times side C times the sine of angle A. There's actually 3 variations on this formula. Another one is area is equal to 1/2 A times C times the sine of B. And then we have our last one, area of a triangle is equal to 1/2 A times B times the sine, you guessed it, C. So there's actually 3 formulas that we can find the area of a triangle, even if we don't know the height. As long as we know an angle and 2 sides on either side of that angle, then we can find the area of a triangle. In fact, this works when the triangle info is a sassy triangle, side, angle, side. Now, there's another way to figure out the area of a triangle. An old dusty Greek dude named Heron. Some people call him Hero. Heron's theorem. Again, Heron is an old dusty Greek dude. He was born in the year 10. Back in the day. Anyways, Heron's theorem says this. It says the area of a triangle is equal to the square root of s times s minus a times s minus b times s minus c, where, let's put that here, where s equals the semi-perimeter, I forgot how to spell perimeter, which semi-perimeter is a plus b plus c, and then divide by 2. You find the perimeter and you divide by 2. Another way to do that is another way to say that is 1/2 times the perimeter a plus b plus c. Now, this happens when we know what A, baby B, and baby C are when we have side triangles. All right, so those are 2 tools that we have to find the area of a triangle when we don't have the base and the height. So let's do a couple of examples here. The first example here we're going to do is we're going to draw a triangle that is We're going to call this angle A, B, and C. And angle B is 36. Side C is going to be 7. And side A is going to be 10. Now, this is side angle side type of information. So we're going to use one of the first ones that we did. Now, we have angle B. So clearly we're going to use our angle B, our sine B sensibilities here. So our area is going to be 1/2 times 7 times 10 times the sine of B, which is the sine of 36. Now, my calculator here has been on the fritz as of late. I don't know what's up. I can't go and get it to open. But if you put that in your calculator, long story short, you should get about, the area is about 20.6. Now, what are the units? They didn't give us units here, but we're finding the area. And area, of course, are units squared. So while they didn't give us actual units, how about we call these arbitrary units squared? Because if it was inches, it'd be inches squared. If it was feet, it'd be foot squared. So whatever the units are, however arbitrary they might be, could be parsecs squared. All right, and then our last example is going to be a side triangle. So side triangle. I'm going to call this ABC again. This side is 5, 6, and 9. Now, since it's side, we're going to use our boy Hero's formula here. And the first thing we might want to find is the semi-perimeter, or S, because there's a bunch of S's inside of there. So S is equal to the perimeter, 5 plus 6 plus 9, but it's the semi-perimeter, so it's half of that. So 5 plus 6 is 11 plus 9 is 20, divided by 2 is 10. So S is 10. So now we're going to apply that to our area formula. Area equals the square root of 10 times 10 minus 5, 10 minus 6, 10 minus 9. Take the semi-perimeter minus each one of the sides. Turns out to be the square root of 10 times 5 times 4 times 1, which is the square root of 200. Now, if I wanted exact answers, make a tree out a square root of 200, you should get 10 root 2. But if I wanted approximate, put that in your calculator, you should get about 14.1. What kind of units? Whatever the arbitrary units squared are. So I would accept either of those. Make sure you put units on that. So you can still find the area of a triangle without knowing the base and height. There's two alternate ways of doing it. We have these sine formulas, and we have Heron's theorem. That's what's up. Smith out!